Welcome to the next session of our 8th module on laboratory testing of microgrid. After understanding the concept of power hardware in loop and its significance in power systems, let us now understand one such application wherein a microgrid model has been tested using power hardware in loop and a real-time load. This is the microgrid model with 600 nodes containing various renewable sources such as wind turbine, solar panel and battery. There are 3 different loads. In our experimental setup, we have replicated one such load with a real-time 3 kilowatt lamp load. What we are going to study today is how does the load get affected when there is an islanding. That means when the main grid is disconnected and the only source to the load is through the either wind turbine or the solar panel. Let us now understand the experimental setup which we are going to use today for the simulation of the microgrid in real time. This is the microgrid model in MATLAB Simulink environment. It basically consists of 600 nodes distribution network and various renewable energy sources such as wind turbine, solar panel, battery bank and 3 loads. This model is then tested on a real-time simulator OP4510 and through the grid simulator, it is connected to a 3 kilowatt lamp load. We are also sensing the current signals from our load via the Hall effect sensors and feeding them back to the real-time simulator through the analog in. Now, why do we require these Hall effect current sensors? This is because the simulator is working in signal level, however, the load is in the power level. As I said, the signals from the Hall effect current sensors are being fed to the real-time simulator through the analog in, and the same you can see in the real-time environment also. Now my colleague Nigam will explain to you how does the lamp load get affected if there are variations in the grid.
So now, as you all know, this is a MATLAB model of microgrid setup. So as of now, we have understood what are the parts of this entire setup we have in simulation platform and what all we have in a hardware setup, right? So as it was shown earlier, this is a MATLAB model of microgrid wherein we have different renewable resources and certain house loads. Now one of these house loads is being replaced by this 3 kilowatt lamp load. So let us see how it is connected. So you can see here we have a control current source. Okay, so to this control current source we are actually feeding the analog voltage or current, which is analog current, which we are actually sensing with the help of the Hall sensors and bringing it inside the simulator as an analog in signal. So with the help of this entire setup, what we can achieve is we have connected this hardware load directly to the real-time simulator, okay, through the analog in channels. Now whenever there is any kind of variation in the entire microgrid setup, we will see that this load is also getting affected. So let us see how it works. So we are able to observe that the intensity of this lamp load is reducing because of certain malfunction in the grid. So again the intensity has reduced further still, and we can see like whenever there is complete cutoff of the grid, okay, the entire lamp load is disconnected now. It is not being able to receive any kind of power from the grid. In today's session, we understood what is power hardware in loop, what are the benefits of power hardware in loop, how power hardware in loop is achieved with the help of a real-time simulator, a grid emulator. And also we took the help of certain sensors and analog input channels. So in this we understood how a microgrid simulated model is connected to a real hardware, and this is nothing but power hardware in loop. So I guess by now you all must have understood what is PHIL and what is the use of real-time simulator in this PHIL setup. Thank you. See you soon.